Hi there, welcome back to my channel. In this video, we are going to treat diagonally dominant matrix. So when you say a diagonally dominant matrix, what do you mean by diagonally dominant matrix? So generally, every diagonally dominant matrix will satisfy the condition the absolute of what aii is greater than or equal to the summation of the absolute of what aij, right? Yeah, so you know that aii are elements on the principal diagonal a11, a22, a33 to ann for every square matrix n by n, right? So if we want to see if our matrix is diagonally dominant, then it means that when I take absolute of each of these diagonal entries, it should always be greater than or equal to the sum of what the other entries row wise. So when I take every row, right? When I take every row, the absolute of my diagonally dominant entry, the absolute of my what principal diagonal entry should always be greater than or equal to the sum of what the other row members. That is the row, other row members. Okay, so assuming that I have something like 2 1, let's say 0, right? And I have 3 6 1, and I have, let's say, 1 0 4, right? So realize that in each row I'm having my diagonal entries, that is the principal diagonal entries, being what bigger. So this is what you do. You realize that the absolute of 2. So if 2 had been negative, let me make this place negative. Let's say negative 4, right? If 2 here, you just take the absolute of it. It should be greater than or equal to what? Absolute of 1 plus absolute of 0. And it's true. 2 is greater than or equal to what? 1. Meaning this part satisfies it. When I come to the second one, 6. Absolute of 6 should be greater than or equal to the absolute of 3 plus 1. You get 4. And it's true. Then finally, we have negative 4. So you should take absolute of negative 4. Right? That will give us 4. Should be greater than or equal to the sum of what? Absolute of 1 plus absolute of 0. And indeed, this one too. Therefore, you can say that this matrix here is what? A diagonally dominant matrix. So let's solve this problem I have here. It says, consider the matrix 10A, 010, A0A. It says, determine the range of A such that our matrix A is strictly diagonally by what? Rows, right? So how do you solve such a problem? So to solve this problem, you know the criteria. I said AII, absolute of AII is always greater than or equal to summation what? Absolute of what? AIJ, like this. So with this, when I come to my matrix, for this row, 1 should be what? Greater than or equal to absolute of what? 0. Absolute of 1 should be greater than or equal to absolute of 0 plus absolute of what? A, right? So using this alone, I can find it. I can also come and use what? The last row, wherever A is. It should be the same. So 1 should be greater than or equal to, this will give me what? 0, right? This will give me what? Plus A, right? So 1 is greater than or equal to what? A. Therefore, A will be less than or equal to what? 1. So the range of values of A is what? Any A less than or equal to what? 1, right? Any A less than or equal to 1. Any A less than or equal to 1. Let's see if we had used the last row. Using the last row, you would have got what? This is the diagonal entry, right? Diagonal entry. So it's the same thing. 1 will also be greater than or equal to what? The absolute of A plus the absolute of what? 0. And obviously, we are going to get A to be less than or equal to what? Absolute of what? 1, right? Absolute of 1 or 1. That's like that. So there is a range, right? This is the range. So you can express this in an interval form as what? From what? 1, negative infinity to what? 1, right? 1 inclusive, like this. So thank you for being with me in this video. Don't forget to like, subscribe, and share.